Hello everyone, happy to see you here. Welcome back to my channel High Mathematics. Today we have very interesting and in the same way this is a very tricky question because a lot of students may be thinking, okay, we have square root of 121 minus square root of 120. Maybe we can subtract square root of 121 minus square root of 120. As a result, maybe we have 1 and the correct answer is square root of 1 equal to 1. But this is a wrong way. How can I solve this question? Right now I'm going to show you how can I solve this question correctly and step by step. First of all, what I want to underline, square root of 121 equal to 11. So let's start with it. Let's try to simplify this and write step-by-step explanation. So first of all, square root of 121 equal to 11. Everyone knows about it. So square root of 121 equal to 11. And minus, what about this 120? This is a good value, good number, because we can easily write it. Let's start with the 4 times 30. Let's start with it. So 4 times 30, this is the way how can we express this 120. So minus square root of 4 times 30. Okay, what we're going to do next? Right now we need to know a really important property. I think everyone knows about it. So when we have square root of a times b, we can easily split it like square root of a times square root of b. So it works perfectly with multiplication and division. In our case, we have multiplication, so this property works absolutely perfectly. So let's start with that. So square root of 11 minus square root of 4 times square root of 30. What is our next step? Of course, square root of 4 is equal to 2. So let's remember it. Don't forget about it. This is our table case. It helps us a lot. So 11 minus square root of 4 is equal to 2. But what about this 30? We can express it in another way. Let's use, for example, let's start with the 5 times 6. It's a great way. How can we express this? 15 times 2 is also great, but let's use this one. So 5 times 6, 15 times 2 is also good. And the bad way to express it as 30 times 1, because it changed anything for us. Yeah, let's use 5 times 6. So 2 times square root of 5 times 6, and let's split it according to this property. Let's do this. So square root of, we have 11 minus 2 square root of 5 times square root of 6. Square root of 5 times square root of 6. I really hope you understand it. It's not the hard step, so I really hope you get it. And after this step, a lot of students don't know how can we continue our solution, because 11 we can't express this, square root of 5 we can find, square root of 6 of course we can split it like 2 times 3, but it doesn't help for us. And right now I'm going to show you how can we solve this, what is the main idea to solve this question. And instead of this 11 minus 2 square root of 5 times square root of 6, we need to create a square. So what I mean, for example, imagine you have square root of like 3 square. What does it mean? It means that we can easily cancel our square root sign, we can cancel these 2, and as a result we have 3. So as you can see, it simplifies us a lot, because then we can cancel square root sign, we can cancel 2, and as a result we have our answer, which is our answer in our question, yeah? And in our case, let's try to create a square instead of this expression. And what is the main idea? When you have this expression, when we raise to the second power, we can easily cancel square root sign and these 2. This is great, but we need to remember about absolute value brackets. So this is the main idea. Instead of this 11 minus 2 square root of 5 times square root of 6, we need to create a square. But how can you do this? I really hope you understand, you remember a really great formula. This formula looks like that: a minus b square to the second power. How does this formula looks like? A square minus 2ab and plus b square. If you look closely, okay, we have 2 right here, so we have something in common, but we don't have 3 expressions. So how can we do this? First of all, let's, instead of this 11, let's write 5 plus 6. Okay, let's do this. So instead of 11, we write 5 plus 6. So square root of, so we have 5 plus 6 minus 2 square root of 5 times square root of 6. And as you can see, we have more elements in common comparing to the previous expression. Right now we have 5, we have 6, we have square root of 5, we have square root of 6. But what is the final trick? Instead of this 5, we're going to write square root of 5 to the second power. Okay, instead of 5, we're going to write this one, square root of 5 to the second power. Okay, it changed nothing because we can easily cancel it. We have absolutely the same result. On the second position, I'm going to write this expression, minus 2 square root of 5 times square root of 6. And the final step, we have this 6, but this 6 we can easily write as square root of 6 to the second power. So plus square root of 6 to the second power. And right now, let's compare this formula, this identity, this formula, and the expression that we have, okay? Right now, I'm going to write it on the bottom of it. I'm going to write this formula real quick. So we have a squared minus 2ab and plus b squared. Let's compare. Let's find out what do we have in our question. We have a squared, for example, square root of 5. This is our a, yeah? So we have a squared. We have also our a right here, not a square, but a. We have 2. We have our b right here, and we have our b squared. So this is our formula. This is our identity. So as a result, we can write it as square root of a minus b to the second power. A minus b, so square root of 5 minus square root of 6 to the second power. Okay, I really hope you understand it. And the final step, as I said before, we have right here our main property. When we cancel it, we can easily write this expression without a square root sign, without second power. We can write it with absolute value. So we can easily cancel this. And our answer, I'm going to continue right here. So our answer, square root of 5 minus square root of 6 with absolute value. This is our answer, but in our case we can easily simplify it, because if this absolute value, if this bracket, if this expression inside these brackets is positive, we can easily get rid of this absolute value bracket. But if this value is negative, we need to put minus before this absolute value brackets. In our case, square root of 5 is less than square root of 6, so it means that this expression is a negative, so we need to put minus this expression, square root of 5 minus square root of 6. This is equal to square root of 6 minus square root of 5. And this is our answer to this question. In 1 minute, I'm going to explain you why we put absolute value brackets and how can we avoid these absolute value brackets. If this expression is positive, for example, square root of 6 minus square root of 5, we don't need this absolute value brackets because this expression is obviously positive. In our case, this expression is negative, so every time put this absolute value brackets. So if you're talking about approximately answer, sometimes a lot of students know about, for example, square root of 6, which is approximately equal to 2 point, yeah, we have right here 2.449. And for example, square root of 5, a lot of students might know it. So square root of 5 approximately equal to 2.236, and you can easily like estimate this answer, because we have, as a result, we have like 2.45 minus 2.24, which is approximately equal to 0.21. Just in case, if you know it, you can easily write approximately answer, but we are interested only in this answer. Okay, we have square root of 6 minus square root of 5. This is our answer to this question. So our answer to this question, this expression, square root of 121 minus square root of 120 is equal to square root of 6 minus square root of 5, square root of 6 minus square root of 5. And if you know this value, for example, this is like a table case, you can easily estimate this answer. If you're talking about approximately answer, 0.21. This is our answer. And right now, a few words about this absolute value, because a lot of students don't get it, why we need to put absolute value brackets. For example, imagine this is our second part of this class right now. For example, imagine you have square root of like right here we have square root of 3, for example, minus 1 to the second power. Okay, everyone knows. Okay, as I said before, we need to cancel it. Okay, I'm going to cancel it, and as a result we have square root of 3 minus 1. In this case, square root of 3 is greater than 1, so this expression is positive, so we can easily leave it like that. Square root of 3 minus 1 is our answer. But as I said before, in our case, as you can see right here, we have square root of 5 minus square root of 6, so this expression is negative. For example, I'm gonna write, let's write square root of 3 minus square root of 18 to the second power. Okay, as I said before, just cancel it without any problems, and every time just write absolute value. It's not that hard. So we have square root of 3 minus square root of 18, and as a result, square root of 3 is less than square root of 18. Okay, so this expression is negative, so we have minus, and we need to put parentheses, square root of 3 minus square root of 18. As a result, we have absolutely different answer, square root of 18 minus square root of minus square root of 3. So this is like a few really important hints. I really hope you get it, because this is important part, to be honest, because we have two completely different answers. If you have a test, if you have A, B, and C, and A you have square root of 3 minus A square root of 18, and B you have square root of 18 minus 3. These are completely different answer. And the main trick is to write, when we are talking about even powers, it not works with the cubes, with the fifth power. If you're talking about even power, this expression can be positive, can be negative, so we need to put absolute value, and then we check real quick, and we have our answer. So I really hope you understand my explanation. I really hope you understand this solution. It's not that hard with the basic algebraic manipulations. So we express it, we expand it real quick, and in the end, like, the main idea of this question is to create a square. Instead of this square root of 121 minus 120 is to create a square, because without a square it's absolutely impossible to simplify this a lot, because if you don't have a square, it's really hard to, you can easily like split it, you can easily split this one, maybe something you can factor as a common, something like that. But with this method you can easily be proud of yourself, because we don't have like a main square root sign. We have a great expression, and of course we can't simplify this more. Square root of 6 minus square root of 5. Sometimes, if you know the table case, you can easily say to your teacher, okay, I know approximately answer. This is also great. Yeah. So I really hope you understand my solution, and of course few tricks, few really important hints, because a lot of students forget about it, and this is extremely important sometimes. So thank you for your time. Take care of yourself. Also write your question, write your response down into the comment section. Let's discuss a little bit about this type of question, and see you in the next videos. Have a great day and take care of yourself.